Let's look at an example of radioactive decay. Strontium-90 has a half-life of 28 days. So when we say something has a half-life of 28 days, what does that mean? What half-life means is this is the amount of time it takes for half of the substance to decay. Okay, so in this particular case, it means if you started off with a certain amount of strontium-90, then after 28 days, half of it will be gone. Let's take a look at example 2, part A. A sample has a mass of 50 milligrams initially. Find a formula for the mass remaining after T days. So when we look at this particular example, we know that the general answer, the general solution to our differential equation is going to be P of T is equal to C times e to the kt. And when they tell me that it has 50 milligrams initially, they're really telling me the value of C. So this means that I can really insert a 50 for C. The problem is we need to find out what K is. So the question is, what is K? And the way that we're going to find K is we're going to use this idea of half-life, okay? So why don't we write a formula down that will help us solve for K? So we know that after 28 days, half of the original amount remains. So we're going to set up this following equation. Half of 50 is 25. So I know that 25 is going to be equal to 50 times e to the k, and then my t was 28, so I'm going to put in a 28 for my t like this. Okay? And then we're just going to solve this equation for k. So if I divide both sides by 50, I'm going to get 1/2 is equal to e to the 28k. And then I can take natural log of both sides. So this tells me that natural log of 1/2 is going to be equal to natural log of e to the 28k. And we know that natural log of 1/2 is the same thing as natural log of 2 to the negative 1, right? Because 2 to the negative 1 is 1/2. We also know that natural log and e are inverse functions of each other. So we know that when you compose natural log with the exponential, you're just going to get the original x back. So this right-hand side is going to be equal to 28k. And when we piece all this together, this means that k is equal to negative natural log of 2 divided by 28. So the reason why I took the time to change this 1/2 to t to the negative 2 and then bring that power down in front, so we see the negative here, is that I really wanted to emphasize that in a radioactive decay situation, our constant rate of change, our rate of growth is going to be a negative number. That K is going to be a negative number. So when we put all of this together, we end up with the following equation. We end up with P of T is equal to 50 times e to the negative natural log of 2 over 28 times t. And let me highlight that. This is going to be our answer. for part A. Let's take a look at part B next. It says, find the mass remaining after 40 days. So in this case, we just need to substitute in a T for 40. I'm sorry, a 40 for T. So when we look at part B, we are going to get P of 40. That's going to be equal to 50 e to the negative natural log of 2 over 28 all times 40. And let me put that into my calculator. We end up with a rounded answer of 18.6. Okay, so I am going to highlight that. This is the amount of strontium we have left. Oh, let me make sure I include the units. That's going to be in milligrams. Great. So let's take a look at part C next. Part C asks, how long does it take for the sample to decay to a mass of 2 milligrams? So in this particular case, I want to set the output of the function equal to 2 milligrams. And then I want to solve for t. So this will be 2 equal to 50 e to the negative natural log over 2 divided by 28 times t. And I'm solving for t. So I'm going to divide both sides by 50. I get 2 divided by 50 is equal to e to the negative natural log of 2 over 28 times t. Then I'm going to take natural log of both sides. So taking natural log of both sides gives me natural log of 2 over 50 is going to equal to negative natural log of 2 divided by 28 times t. And then I am going to multiply both sides by 28. So I'll have 28 natural log of 2 over 50. And then I'm going to divide both sides by negative natural log of 2. So divide both sides by negative natural log of 2 times, and that will be equal to t. So I take this expression, I plug it into my calculator, and I get approximately 130 days. All right, so let me highlight that guy. It's our answer for part C. And the last part says sketch a graph of the mass function. I think I'm going to skip that, but the basic shape is going to be a transformed uh, exponential graph. So let me just draw a quick sketch for you. So you can use Desmos to actually graph it properly, but very roughly speaking, your graph is going to have some, axes like this. This axis is t, and this is measured in days. This vertical axis is the population, and that's measured in milligrams, or that's the amount of strontium-90 that we have. We know that the graph is going to start at 50. So that means that the intersection of the vertical axis is going to be 50. And we know that it decays exponentially. So it decays something like this. Okay. So this is a very rough shape of our P of t graph, but you could use technology to graph it more accurately. I guess the key thing is that this is an example of exponential decay. I'm not going to lie, I don't love my sketch. I think this should be like a lot steeper here and flatten it out, but This is just a rough idea. All right, everyone. Take care.